Alright, so today we will be beginning with the fourth chapter of O level in IGCSE Computer Science, which is called software. So let's begin with the first topic that we will study today, which is the types of softwares. So the first type of software is called a system software. Alright, so these are all of the softwares that provide the necessary services and infrastructure that a computer requires. Alright, so if you ever bought a brand new PC or a laptop, you will see that it comes with pre-installed softwares, one of which is an operating system. Alright, so Windows, Mac OS, Linux, these are all types of operating systems. Next, you have a few utility softwares such as disk defragmenter, antivirus softwares, and other softwares like that. So these together are all the softwares that are required by a laptop or a PC to run efficiently and in an optimal state. Alright. So coming on to the second type of softwares, which is application softwares. Alright, so these are all of the softwares that are designed to help users perform specific tasks. Alright, so let's just suppose that if you want to play a few games, you will want to download software such as Call of Duty or Valorant, stuff like that. If you want to edit documents, you will download Microsoft Word or any other type of productivity software, right? So these are basically the softwares that a user can download according to his needs rather than it being actually pre-installed in a laptop or a PC. Alright, so coming on to the detailed explanation of operating systems. So I told you before that operating systems are basically types of system softwares, right? So there are two main types of operating systems, which are the graphical user interface operating systems and command line interface operating systems. So if you've ever used Windows or Mac OS, these are basically types of graphical user interface operating systems. Alright, they have windows, icons, folders, menus, and stuff like this, so that it makes the life easier for the user. Alright, however, if you have Windows and you type on the search bar command line, you will see that an app opens up where it's basically just a box with white text on a black background, right? That is basically just command line interface. Alright, this basically allows the user to manipulate some stuff on the laptop that cannot directly be manipulated using a graphical user interface, right? So graphical user interface is a rather heavy type of operating system because it has a lot of background processes going on. However, if you just have a command line interface, that is, even though it is harder to use, it is very efficient and it is very fast to use. All right, however, you need to know that the command line interface actually requires you to learn a lot of commands and stuff like that, and something that is as simple as copy and paste inside the graphical user interface can take a few minutes to type in all the commands so that you can move the file from one place to another. Right, so that is basically just the two main types of operating systems. Now let's just study a few basic functions of an operating system. So the first type of function is basically just file management. All right, so you probably have a few folders on your laptop or PC which have, maybe you have a separate folder for schoolwork, maybe you have separate folder for your games, stuff like that. So that is basically just the operating system managing all of the files and directories, right? Next up, let's just study about multitasking. All right, so operating systems basically allow multiple programs to run simultaneously, right? So giving certain types of instructions to the CPU allow users to actually perform multiple tasks at the same times, right? So if you have a browser opened up alongside a game and all the other software are running in the background, right? So this is basically just the operating system allowing a user to do multitasking. All right, so there are a few other functions mentioned here as well, so make sure that you go through all of them. However, I recommend that you remember at least 4 of them. All right, so coming down to hardware, firmware, and OS. So what you need to know is that a laptop or a PC or anything, even a smartphone, is basically just a mixture of hardware, firmware, and operating system working together. All right, so the hardware is actually just the physical foundation of the computer system, right? So the screen, the speaker, the microphone, all of that is basically just the hardware. Secondly, we have the firmware. All right, so this is actually the basic software that a computer requires so it can boot up the operating system. All right, so if you turn on your laptop, you will see that it will have maybe a Dell logo or an HP logo for a few seconds, and then it moves on to the actual operating system, right? So during that time that it has a black screen with a white logo on it, that is basically when the firmware or the bootloader is actually loading up the operating system into the RAM. All right. And last but not least, we have the operating system itself, and this is basically the thing that allows us to communicate with the computer so that we can perform tasks, as I mentioned before as well. So now let's come down to interrupt handling. All right. So interrupts have been mentioned a few times before as well. So you can see that interrupt handling is actually one of the tasks of operating systems, right? Over here I've mentioned that interrupt management is a task that is performed by an operating system. And then there are a few other places. For instance, when a keyboard is basically, when you press a key on a keyboard, that is when an interrupt is generated, right? So now we'll just study what an interrupt is. First of all, what you need to know is that an interrupt is basically just a simple signal that is sent to the CPU. All right. So let's just learn about how an interrupt is generated. So over here you can see that I have mentioned two different types of interrupts, which are hardware interrupts and software interrupts. So basically an example of an hardware interrupt is when a key is pressed on a keyboard which sends an interrupt signal to the CPU, right? So this is basically telling the CPU that a key has been pressed on this keyboard, and therefore it requires the CPU to maybe type a letter on the screen or something like that. All right. Next up, when a printer is basically finishing a print job or it is doing something, right, and let's say suppose that it runs out of ink or something like that, it will send an interrupt, which is basically a signal to the CPU to tell the user that we have run out of ink. All right. So those are basically just examples of hardware interrupts. Next we have software interrupts. All right. So software interrupt can be triggered if a program attempts to divide a number by 0, right? So dividing something by 0 is basically an impossible task, right? That is not possible because, well, it's pretty complex, right? So anyways, if you want to divide something by 0, that is an impossible task, and because computers cannot actually calculate something that is impossible, it will give an error. All right. Next, you can have a software interrupt if a program tries to access a memory location that it is not allowed to, or maybe it does not even exist. So these are just examples of software interrupts. So moving on to how an interrupt is handled. Alright, so this is very interesting. So make sure that you listen to this closely and make sure that you remember these steps step by step. Alright. So first of all, when an interrupt occurs, right, so for instance, if I press a key on a keyboard, an interrupt is generated, the CPU will receive that interrupt signal, right? Next, the CPU will save the current state of its registers and program counter, right? Then it will jump to a specific memory location where the interrupt service routine is stored, right? So the CPU saves its current state and then moves to a specific software called the interrupt service routine. So the interrupt service routine is basically just a special function that is designed to handle interrupts. All right. It processes the interrupt and performs the required task, right? So for instance, if you have an interrupt that's generated by a keyboard, that will basically, the interrupt service routine will basically send a command to maybe the screen to show that kind of letter on the screen. All right. And maybe there's some other kind of interrupt, so that processing and all of the sending of signals, that is handled by the interrupt service routine. Next, when that interrupt has been handled, the CPU will restore the saved state that is saved before, and then it will just resume executing. Alright. So the CPU will first receive that interrupt signal, it will save its current state, load that interrupt service routine. The ISR will then manage the interrupt that it gets, and then it will restore the CPU's current state, and then the CPU will go on performing its original task. Right. So let's move on to what happens as a result of interrupts. Right. So interrupts, first of all, can be prioritized. Right. So let's just suppose that we are performing a few different tasks at a time. All right. If we are typing something on the screen, and also we are recording something on the screen, right, and we are also listening to something at the same time, but at the same time we get a notification from the antivirus software on a laptop that there is a very malicious file on your computer that may permanently damage your laptop, right? So it will obviously be more important for the CPU to handle the first type of interrupt, which is actually from the antivirus software, rather than actually just handle the interrupt from my keyboard and mouse and microphone and speaker, right? So that is basically what we mean when we say that interrupts can be prioritized. Anyways, moving on to the types of programming language and translators and IDEs. Alright. First, let's study about high-level languages and low-level languages. So let's begin with high-level languages. So high-level languages are basically just programming languages that are abstract and closer to human languages, right? So if you've ever worked with maybe Python or C++, those are basically types of high-level languages, right? So over here you can see that I have given a simple for loop, right? So this is, we will actually study this later on in chapter 7 and 8. However, you do not need to remember this now. This is just for an example. All right, so this is a simple for loop inside a high level language, which is Python right now. However, over here you can see that a low level language has the same type of loop, but it is much longer, right? It is much larger than the loop that is in the high level language. So you can see that high level language is actually very easier to write, and it is also less lengthy, right? So this is one of the advantages of using a high level language. Secondly, these are machine independent. All right, so this means that the same code can run on different types of computer hardware. So the Python on my PC and the Python on your PC will basically be the same, right? So if I copy my code and paste it on your computer, it will basically work in the same way as it did on my PC. However, there are a few disadvantages, right? So first of all, high level languages may run slower, right? So because these commands will still have to be converted into binary, right? They will require a little bit more processing to actually convert them into binary. Alright, so next let's move on to low level languages. So low level languages are closer to machine code and provide little to no abstraction, right? So an example of this is basically the assembly language. So over here you can see that this is an example from an assembly language, right? Over here you can see that this is obviously much harder to read and write, and also debugging these types of languages are also very problematic, right? So debugging is basically when you have to find errors inside a certain function or a program that you have written. All right, so over here you can see that there are 7 different lines, right? So finding an error inside 7 different lines and finding an error inside just 2 lines will obviously make a huge difference, right? Because 7 lines basically means that is almost being tripled in size. All right, so therefore it will be much difficult to handle errors. However, they do have a few advantages. First of all, they allow direct access to the hardware, right? So because these are very close to machine code, they allow a lot of different types of commands that can be entered that are not necessarily included inside high level languages, right? And also they can be highly optimized for speed and memory usage, right? As I told you before, they're very closer to machine code than high level languages, therefore they are faster. Coming down to assembly language, right? So this is basically a type of low level programming language, right? So first of all, what you need to know is that assembly language includes mnemonics. Alright, so over here you can see that MOV is basically just a mnemonic to move data from one place to another, and then ADD is basically a mnemonic to add 2 values. Alright, so this basically makes it a little bit easy to write these kinds of programs. However, it is still very difficult and lengthy task compared to high level languages. Next, you need to know that in order to convert the assembly language to machine code or maybe binary, you will have to use an assembler. Alright, so we will actually study compilers and interpreters which are used to convert high level languages into machine code, but for an assembly language we will use an assembler. Alright, so let's just study the process of assembly. First of all, what you need to know is that when a programmer writes the assembly language, he uses mnemonics and labels, right? So I showed you a few examples of mnemonics and labels above. Next, the assembler will read the assembly language and translate it into machine code, right? So it already has the translations of the certain mnemonics and labels that we will use inside assembly language, right? So all it has to do is basically see all of the mnemonics that we use and convert them into machine code with the pre-written translations of into machine code. All right. Next, the assembler will produce an output file containing the machine code, which can then be executed by the computer's processor, right? So basically, the assembler is just converting assembly language into machine code, and then it produces a file that can be executed by the computer's processor. Next up, let's learn about translators, which are basically just compilers and interpreters. Alright, so first of all, you need to know that high level languages need to be translated into machine code. Alright, so high level languages itself are not actually binary, right? They have to be converted into machine code which is understandable by the computer, right? So the first example of a translator is a compiler, right? So the first type of translator is called a compiler. So now let's study the process of a compiler. First of all, the compiler checks all the code before executing any code. Alright, it will basically go through the whole code and then it will produce an error report with all the errors found inside the whole code, right? So then it will optimize the source code and then produce the executable file. So first what it will do is basically it will check all the code for any errors and it will produce an error report. Then it will optimize the source code, right? So it will make sure that we do not have a lot of long lines that can just be written as shorter lines, alright? And then it will just produce the executable file. So let's just study a few advantages and disadvantages of a compiler compared to a interpreter. Alright, so the first advantage is that the resulting executable file is optimized and therefore runs faster, right? So optimization is not exactly done by an interpreter, rather it is performed by a compiler, which means that a program that is converted into machine code using a compiler will be relatively faster. Alright, so coming down to a few disadvantages of the compiler. First of all, the compilation process can actually be a little bit more time consuming. Alright. Secondly, the errors are reported after the entire code is analyzed, which is not actually the case with interpreters. So let's just move on to interpreters. So first of all, an interpreter is basically translating high level language to low level language one line at a time. Alright, so over here you can see that the compiler takes the whole file at the same time and converts it into source code at the same time. However, a translator is actually converting and executing the program one line at a time, right? Next, you can see that it will then run an error diagnostic, right? So if when it is translating each line, if it comes across an error at that specific line, it will stop the program and then it will prompt the user or the programmer that there is an error over here, right? So next you can see that it will stop the execution when it encounters errors, as I just told you, and lastly it will continue translating when the error is fixed. Alright, next let's just study a few advantages and disadvantages of interpreters. So first of all, programs can be run and tested relatively quickly to a compiler, right? Secondly, errors are reported as soon as they are encountered, right? So as I just told you, compilers produce a whole error report before actually telling the user that there are errors in this. However, in this one, in interpreters, they basically just tell it as soon as they encounter one. Disadvantages are that interpreter programs generally run slower, right? Because you're executing each line one at a time, right? That is basically slower than actually compiling a program and then running it. Alright. Secondly, the source code and the interpreter must be present on the system. Alright, so in this case, this is a disadvantage for interpreter, that it will basically need the source code. Alright, so source codes are basically very crucial when it comes to distributing software that are basically paid, right? So you can't actually give paid softwares that includes the source code, right? Because then people can copy it and then sell it for free, right? So that is actually one of the disadvantages. If you have to ship a source code along with the program, that is a huge disadvantage. Anyways, coming down to IDEs. So an integrated development environment. So this is basically the software application that we use to program, right? So when we go on to the chapter 8 and chapter 7, we will use an IDE to write high level languages. All right, so that is basically just the software. For instance, to write Python, you use PyCharm, right? So that basically has a few errors that makes it very convenient to program in that specific application for the programmer. So let's just study a few of the features, right? First of all, they already have the translators built in, right? The compilers and the interpreters are already built into the application, and you don't have to download them separately. Secondly, they have auto completion, right? So let's just say you're writing this for statement over here, right? Let's just say that you're writing this for statement. So when you get to for, it will automatically give you a prompt, right, that you can complete this whole thing by just pressing tab. All right, and then you can maybe edit the range that you want to put in, right? You can put in 100 by yourself. It will automatically give you an option to expand this whole thing and actually extend it by itself, which is a very convenient tool for a programmer. Then you can see that it has pretty print, right? So over here you can see that I have colored each of these things differently, right? So the range and print are basically functions, right? So they are basically colored in different way, and these are keywords. For and in are basically keywords, so hence they are in a different color. So this is very convenient for a programmer when he is programming, because this helps us identify where each thing is and where I actually have to edit something so that I can change how a program is performing, right? So I think this is pretty much it for this chapter. Alright, so I hope that you like this video. Make sure to like my videos and subscribe to my channel, and I will be uploading more videos more often. Also make sure that you share these with your other friends who are studying the same subject. Alright, I'll see you later.